In this video, we are going to look at example 5 on page 128. We're going to look at example 5a to be exact. So we want to find the power series centered at a equals 0 for f of x equals 1 over 1 minus 2x by not finding the Taylor series, but rather using the method from a couple of examples ago, where we want to use a well-known power series expansion that we already have and plug in something useful to find the power series expansion of this new function, 1 over 1 minus 2x. And when you're looking at the structure of 1 over 1 minus 2x, take a second to look back at the box on page 127 and see if there's a power series expansion that might be helpful. You may have found that 1 over 1 minus x has basically the same structure as the function that we are interested in. And we know the power series expansion for 1 over 1 minus x. It's 1 plus x squared plus x cubed plus x to the fourth and so on. And the interval of convergence was minus 1 less than x less than 1. So this is what we already have. We already know this, and so now we can use it. When you compare the two power series, or the two functions, the only difference is that instead of looking at 1 over 1 minus x, we are looking at 1 over 1 minus 2x. So when I put parentheses around the 2x, we see that when I'm grouping the 2x together, I have the same structure as I had in 1 over 1 minus x. And so we can substitute 2x in for x in our already known power series. So we have 1 plus the thing squared plus the thing cubed plus the thing to the fourth, and so on. And what we want to put in here is 2x. So I substitute 2x in everywhere where I had an x in my original power series. So I have 1 plus 2x squared plus 2x cubed plus 2x to the fourth. And note that I also should adjust the 2x in my interval of convergence. So this is true as long as 2x is between minus 1 and 1. Just like before, right here, I still have the same fact true about my interval of convergence. We can clean this up a little bit. So my series is 1 plus 2x plus 2 squared x squared plus 2 cubed x cubed plus 2 to the fourth x to the fourth, and so on. That keeps going. And my interval of convergence, we would like to describe it just in terms of x. And so what I can do is I can divide by 2 all 3 pieces of my inequality, and that gives me minus 1/2 is less than x is less than 1/2. And that's it. So my series for 1 over 1 minus 2x is equal to 1 plus 2x plus 2 squared x squared plus 2 cubed x cubed plus 2 to the fourth x to the fourth. And written like this, we could also write down the sigma notation. But again, that's not expected. You don't have to do that. But we can see it's 2 to the n x to the n. So we get the sum, n goes from 0 to infinity, of 2 to the n, x to the n, and the interval of convergence that is from -1/2 to 1/2, not including the endpoints.